Welcome to this short video introduction about product line engineering with pure variants. In this video, you will learn about the basic concepts of feature model-based variant management, and the challenges that pure variants, as the leading variant management solution, can help you with. I want to start with a quick introduction to Pure Systems, the company behind the tool Pure Variants. Pure Systems was founded in 2001, and is headquartered in Germany. From there, we and our partners like 321 Gang help customers worldwide to implement product line engineering as a systematic, holistic reuse strategy for their engineering assets. With Pure Variants and its more than 40 tool integrations, our customers stem from various industries like automotive, aerospace, defense, rail, transportation, and many others. They all develop families of complex products consisting of software and hardware, and all face the challenge of how to consistently reuse their engineering assets like requirements, test cases, code models, and parameterization data across their product families. Consistent reuse can be quite complex, due to interdependencies between different engineering assets, that are at times not explicitly captured and formalized, so each development artifact has to be manually selected by experts for reuse in a new variant. To be more efficient, this knowledge has to be extracted and formalized so it can be used for the automation of reuse. To achieve consistent reuse, the formalized interdependency knowledge needs to be established across asset type borders. Therefore, the variant management tool needs to be connected to all engineering tools that hold those assets, especially if the products are functional safety relevant, and have to be developed following functional safety standards, where traceability plays a major role. On top of the traceability that is provided by ALM and PLM solutions, dedicated variant management gives an additional level of traceability that provides you with a view of which variants reuse which engineering assets, allowing you to conduct an impact analysis to quickly understand which variants will be affected by a change. The idea to reuse engineering assets is not new, but without dedicated variants and management, your assets will not automatically end up modularized. And it will not be so easy, as depicted here, to identify which assets can be reused together. In the context of a new variant, after a few projects, you will have a lot of potentially reusable assets, but you will miss a level of abstraction that allows you to grasp the interdependencies between those assets and configure new variants out of them. Many times, Excel spreadsheets are used as a way to communicate the set of functionalities that is part of a product variant. Unfortunately, this representation does not comprise the interdependency information necessary to understand whether a variant is valid, and whether it is still valid after changing its functionality set. Also, the decisions captured in such metrics are not mapped to your engineering assets, so the process of picking the right assets for reuse cannot be automated. Also, a quite common solution is to utilize version control systems to handle variability. With this approach, it is very likely you end up with a lot of parallel development and maintenance due to variant erosion. Over time, the variants will develop apart from each other, making it hard to develop engineering assets only once and reuse them across multiple variants. Also, the change propagation between variants, if possible, would still be manual and error-prone as there is no automated consistency checking taking place. The variant management tool, Pure Variants, allows you to construct a feature model, which integrates with more than 40 different engineering tools. These tools, working together, address these challenges and manage variability across the whole engineering lifecycle. With Pure Variants, you can formalize your expert knowledge about interdependencies, and make it persistent in a feature model that is connected to the supersets of your engineering assets. This enables you to configure product variants based on a central feature model by feature selection. You then are able to automatically derive the needed engineering assets for the respective variant from the superset of these assets. Let's have a look at the basic concepts of a feature model. Feature models are tree structured. Each feature appears as an element in the tree with a unique name and a variation type. There are 4 different variation types, each depicted with its own symbol: mandatory, optional, alternative, and or. Mandatory features have an exclamation mark in front of their name. This indicates that the feature will be part of each variable variant, and will be automatically selected in any variant model that is based on this feature model. Some child features come in groups, where the choice within the group is optional, alternative, or. When the indication of the group is optional, and their parent feature has been selected, they can be either included in the variant or not. When the indication of the group is alternative, and their parent feature has been selected during variant configuration, then exactly one of the alternative features has to be selected. With or features, if their parent feature has been selected, then at least one of these features has to be selected. Sometimes hierarchy and variation types are not enough to model all interdependencies between features. For this reason, so-called relationships can be established between features of a feature model, and even between features of different feature models. Relationships have types. The type defines the meaning of a relationship. In this example, we added a relationship of type, requires, to the feature start-stop automatic, to express that this feature can only be part of a variant if the feature gasoline engine has been selected as well. There are many other relationship types available in pure variants to express that a certain feature requires another one, or that they are mutually exclusive. Pure variants understands these relationships and can tell you at any time during the variant configuration process, and afterward if a feature selection leads to a valid variant or not, and will also point you at possible solutions to get out of an invalid configuration. Another basic concept supported by feature models and pure variants is attributes. You can add them below each feature. While based on a feature selection, certain engineering assets will be part of a variant or not. Attributes can be used to control parametric variability. If you, for example, have a pulse frequency in your product that is of different values across your variants, you can introduce an attribute to control this value across all of your assets. The attribute gear count in this example can be set once during variant configuration, and will then be injected into the respective requirements, test cases, code, and related models. Attribute values can either be set by the user during variant configuration, or alternatively, you can add a formula to the feature model by which the value is automatically calculated, based on your feature selections, and other attribute values in the model. Let's have a look at how a feature model can be navigated in the Pure Variants Eclipse client, and how variant models can be configured based on feature models. Our example will be based on a fictional product line of front car light systems. Besides the graphical representation of a feature model, Pure Variants can visualize models in a more compact view, to let users see a bigger piece of their overall model. Like the earlier examples, this feature model contains mandatory features like the feature beam configuration, and its children, low beam, and high beam, that will be part of all variants. For low beam and high beam, we must decide to use either halogen, or xenon features. They have been modeled as alternative features, and are therefore mutually exclusive. The model also contains multiple optional features like daytime running lights, or driver assistance. Each of those can be added to the variant independently from the other optional features. If driver assistance is added to a variant, then at least one of its children must also be added. But it is also possible to add more than one, as these features have been modeled as, or features, in the variant configuration. We will make use of this feature model together, with the second one which is called, regions. To configure a new variant, we first need to add a new variant model to our configuration space. In the wizard, we first give our variant model a name. Next, we can optionally decide to inherit a feature selection from an already existing variant. In this example, we do not inherit but start from scratch. In the variant configuration view, you decide which features of your feature model will become part of this specific variant. By feature selection, the variant model exposes the features of all relevant feature models to you. In this example, the functional features and the regions features. During variant configuration, Pure Variants is providing feedback via arrow markers to let you know if a variant is valid or not, and also how to fix it. Features that cannot be added without violating the rules of the feature models are marked with red boxes and a white X inside. The auto recovery will evaluate relations that you establish between features and automatically select features that are needed in combination with the currently selected one. Pure Variants comes with strong variability analysis capabilities like a fine-grained compare and merge view that allows the comparison of different variant models with each other, as well as the comparison of different versions of a single variant model or feature model. Let's first have a look at how to compare two variants directly with each other. The compare view is divided into three subviews. The two bottom views show the feature selection and the engineering assets that are needed for those variants based on their features election next to each other. On the top, your variant shows a list of differences between those variants. In this example, it is filtered to only show different features. On the feature level, the same view can be used to show how a variant changed over time. The current version of the variant can be compared with an earlier version of itself. Version control either happens in an external version control system like Git, GitLab, or IBM Global Configuration Management. Pure Variants can interact with these version control systems via Eclipse, or in a database provided by the on-premise feature model server. In this example, we see how the feature, fog light, has been added to this variant since the last commit. The matrix view visualizes all features of the feature models in one overview. You can find the features themselves in the first column, and next to it, there is a column for each variant model. This way it is possible to see multiple variants in one view. The matrix view also contains the family models. Using this view it is possible to see across asset types, and see which engineering assets will be part of a variant due to its feature selection. Here, we see how the variants make use of parts of our supersets of engineering assets. The matrix view is a good place to compare variants with each other. To make the comparison more comfortable, it is possible to filter the view. Quick filters, like the uniqueness filter, highlights features and solution assets only used in a single variant. The commonalities filter shows assets that are always or never used in any variant. Besides that, the user can define their own filters to filter the view for specific rows and columns depending on their query. All of the information shown in this matrix view can be exported in various formats, including HTML, XML, PDF, and Excel, to make this information accessible to other stakeholders. To get an overview of how features are connected to engineering assets, and how variant-specific assets are generated from a superset, or to learn more, contact 321 Gang, a Pure Systems Pure Variants business partner in North America.